So, good morning. I'm Dr. D. Suresh, Assistant Professor in the Department of Automobile Engineering and working at VNR VJIT from last 10 years. My topic for the session is based on modern automotive technologies. As we know, generally, I will compare the vehicle or maybe an automobile with a human body. So, as we know that basic structure of human body, how it is aligned with uh, like legs, eyes, as well as hands, so and skeleton. So similarly, the automobile also, as we know, a different combination of different systems. In that particular context, I compared with the engine is a power source in a vehicle. It just like in a human heart. Similarly, the wheels with the legs. Uh, like that, every component in an automobile is just a replication of a human body. So, where the human body generates energy by through the digestion process. As we know, in a vehicle, the engine is a power source. So, which can generate the power and supply to the remaining part, so that we can the vehicle is propels on the road. Similarly, human body also generates the power. So it reaches to the legs so that we can move on the road. So only thing the difference between the human body and vehicle is based on the intelligence. So the intelligence, if we add it, it becomes like modern automotive technology. The automotive technology or maybe the vehicle, if it is becomes an intelligent, then we can give an option like modern automotive technologies, so that we can able to cope up or maybe we can able to meet the industry requirements, so that this particular course or maybe this particular contents which are coming to this particular course will be gives an idea about what industry needs, what customer needs, and what kind of technologies which are evaluating in the industry of automobile, so that we can get some idea about the new technologies which are implementing in automobile. So in that particular context, I would like to start discourse what kind of factors which can makes to drive for implementation or maybe adoption of new technologies into the automobile. So as we know, in general, in the automobile we divided entire automobile into three categories. Basically, it's a powertrain and the chassis and the vehicle body. The powertrain includes basically a driveline and power plant. So the power plant is basically an engine, and the driveline includes from starts from the clutch, gearbox, propeller shaft, differential, and the wheels. So whereas in a chassis, it's basically, as we know, it's a control systems in automobile. The basic control systems in automobile is a steering system, braking system, and your suspension systems. And the vehicle body, as we know, it can protect all these components. So but in order to keep all those parts in a single structure, that we called as in a frame. So here these basic parts will be always will be present if any kind of the vehicle. As we know, in today's world also, or maybe the news which came in 2 days before recording this video, we came to that the Nissan would like to launch their autonomous vehicle in 2027, and Tesla is already commercialized the autonomous vehicles as well as the electric vehicle. So as the time is progressing, so more and more of the technology evaluation is included in automobile to the basic structure. The basic structure, as I discussed right now, includes the three subcomponents. So in that particular context, the inclusion of these modern technologies will driven by three or maybe four parameters which are across the globe is acceptable. The most first and foremost important is legislation, environmental and safety regulation. So here the government is looking for basically different technologies, so or maybe environmental aspects and safety regulations, because as we are moving towards the global increase of global population and the lifestyle of the human beings, or maybe the lifestyle of the persons which are in the country as increases, they want to move for, they want to expect their lifestyle also in more luxury way. In that particular constant, every vehicle or maybe every family nowadays holding around 3 to 4 vehicles. So if the that much importance is there in our day-to-day life about the vehicle, in that particular context, if you do not provide a proper safety to the vehicle, there is a uh, what we can say, there is a uh, possibility of not accepting the vehicle is increases. So in that particular context, everybody or maybe the government is also noticed that if you want to launch your vehicle, or maybe if you want to sell your vehicle in a particular country, we need to follow the particular country's safety regulation. These safety regulations will increases as number of context of accidents will be increases, the statistics related to the accident will increases. So the main intention is here to reduce, or maybe to avoid a human life, or maybe not at the cost of the vehicle, cost of your human life, we can't build the vehicle. So here, as the safety is increases, then the technology safety regulations are stringent, then the technology evaluation into the vehicle will be increases. Similarly, legislation and environmental. So as we know the Paris Agreement, so every almost most of the countries are promised to reduce their pollution, or maybe net carbon zero emissions, or net zero emissions, net carbon footprint, or maybe greenhouse gas reduction. So in that particular context, if we are able to use the conventional vehicles which are operated with conventional engine kind, so at that time there is a possibility of not controlling the global gas emissions. So in that particular context, in order to increase, or maybe in order to increase the, or maybe in order to make in order to strictly follow the promise, so we need to include the technology inside the vehicle so that it can reduce, or maybe it can meet the government environmental and legislation issues. And similarly, the customer's point of view, the customer is thinking about some of the customers, they don't bother about the cost, but they want about some kind of high end safety features. And it should be, we can say that in a second concept, image. So the car should be not available with any other any other body in their country, so they want to own, like, so that kind of image is pushes towards the technology development in a vehicle. And emotion, nowadays the car is mandate, everybody thinks that the car is needed, necessary. So at the time, they will think about how different from others. So that also plays an important role in terms of technology development. And the third one is supplier. So the supplier, if a single if I'm depending on a single supplier which can supply to the OEMs, so then there is no kind of advancement in the technology. But as you need advancement in the technologies, or there's customer's requirement, then the supplier always thinks in a direction that what customer is needs, depending on the customer requirement, the supplier will supply the technologies. So these supplier, if more options are available, then we can think of about the technology evaluation. If the supplier will supplies more number of technologies, I can try to include it, like the Bosch, Continental. These are basic suppliers to the OEMs. They will develop the technology. So based on this technology development, we can adopt into the vehicle. And fourth one is OEM sales volume. So every customer, or maybe every OEM is thinks about their sales volume increases. So how it will be increases, when if you are providing a basic difference to the other customers. Like for example, if the vehicle is producing more fuel economy, or maybe in terms of more mileage, then everybody will purchase that vehicle. So the few people are not bothered about the fuel consumption, or maybe basically the maintenance cost of the vehicle. So most of the customers, like Indian kind of environment, Indian context, so everybody thinks about, most of the people thinks about the fuel consumption is a major parameter. So at the time, the vehicle which will provides more fuel consumption, then that OEM will be, supplied vehicles will be more attractive and their volume will be increases. Similarly, some cases, some customers think about the luxuriness cost. So depending upon the customer needs, the OEM has to shift their technology inside the vehicle, otherwise they can't cope up with the market. So just example is the Nokia. So it is not needs the customer, meets the customer requirement, so that it is outdated. So similarly, this thing is applicable to the automobile also. If you are not updated with the technology, or maybe updated with the customer requirement, not updated with the government, not made the government regulation and environmental regulation, or if you are not able to bother about the supplier which are supplying new technology, then your vehicle will be not sustained, our product will be not sustained in the market, you are outdated person. That's why to fulfillment of these demands concerning the function, weight, economy is is decisive for the success of new technologies under compliance of legal regulations. So if you are not able to meet demanding related to the weight reduction or maybe government regulations, it is very difficult to sustain in the market. That's why every OEM is thinking about to adopt the technology into the vehicle. That's why every car nowadays equipped with 50 to 60% is modern technologies. This delays on electronics. So in this particular context, what are the different sources or maybe available places where I can able to introduce the technologies? For example, if you take the drivetrain, as I mentioned, the vehicle is divided into four categories or maybe three categories: powertrain, chassis, and the vehicle body. So out all these, among these three categories where I can adopt the technology, if you look into this drivetrain, basically where I can able to introduce introduce new technologies in terms of, or maybe in place of fuel injection systems, electromechanical electronic fuel injection systems. With this I can able to meet the government emission regulation in terms of BS6, Euro 6, like that. So every country need to meet the emission and environmental regulations. So where this technology adoption like electromechanical fuel control systems will satisfy those requirements, like gasoline direct injection system, multi-point fuel injection system, and common rail direct injection systems. Where we can introduce this technology, I can able to meet two requirements. One is uh, fuel economy will increase for the vehicle by adopting this technology. At the same time, I can able to meet the government emission regulations, so that I can able to launch my vehicle, and further also I can attract the customers more as the fuel economy is more for your vehicle. And second one is the drivetrain, electric vehicle and hybrid electric vehicle. So nowadays every country is looking for adoption of new drivetrain in the vehicle. Instead of a conventional engine, they are shifting towards a motor based drivetrain in terms of battery and motor, so that we can charge the vehicle and we can able to drive the vehicle for a reasonable distance. And hybrid electric vehicle which can extension of the range for the conventional vehicle. If the conventional vehicle having one drivetrain, similarly electric vehicle having one drivetrain, where then hybrid electric vehicle having two drivetrain, that means where I can include both electric drivetrain and conventional drivetrain which is driven by the engine. So both drivetrain will be present, so that I can call it as this hybrid electric vehicle is the range extension towards your conventional vehicle. So there are different options. Are there micro hybrid electric vehicle, mild hybrid electric vehicle, full hybrid electric vehicle, plug-in hybrid electric vehicle. So depending upon the cost, and the customer can choose it by adoption of this technology. Only thing is, it is supplement or maybe additional range which is provided to the electric vehicle, so that I can able to travel more in terms. in terms of efficiency, also I can deal here. That means whenever the engine is operating at low rpms, the efficiency is low. Similarly, the engine is operating at a particular optimum speed range, rpm range, it can provide maximum fuel economy. So here, by using hybrid electric, that means by introduction of electric drivetrain, I can operate it where the engine is having low efficiency, that is low rpm, starting 30 to 40 kilometers, where I can able to operate the drivetrain of electric vehicle. Once the switchover, that means more than 50 kilometers per hour, depending upon the manufacturer, I can shift into the drivetrain of conventional, so that I can able to increase my fuel economy by adopting this two drivetrain technology into the vehicle. And third one is the fuel cells. So where I can't completely avoid uh, conventional energy sources. For example, if it is an electric vehicle, we need the electricity. That electricity is produced at the grid level. Whereas the hybrid electric vehicle, it needs both energy sources, that is conventional grid electricity and conventional fossil fuels to operate your vehicle. Whereas the fuel cell operated vehicles, so they can generate the electricity by using renewable energy source like hydrogen and conventionally and atmospheric air. It can generate the electricity. That electricity we can supply to the battery, so that we can use it in the electric vehicle, so the fuel cell operated electric vehicle. So still there is a lot of innovation is concepts are developing to adopt it into the vehicle for commercialization. And third one is new material application. So as I mentioned, the weight reduction is one of the important parameters. So just like an human being, where if a person is having a large weight, he can't do too much work in terms of walking or maybe the running. So similarly, for in a vehicle also, if the weight of the vehicle is more, it can't, or maybe it can takes more fuel to do the work. So similarly here also, when we added with a new materials which are having high density and the low weight, so that we can able to travel a long distances with minimum fuel consumption. As the vehicle weight is increases, then the fuel consumption will be increases to propel the vehicle. So when you are developing a new materials which can reduce the weight of the vehicle, it is an added advantage. So and similarly, at the chassis level, we can try to include the technologies like active suspension systems, where we can able to provide a better comfort to the passengers or maybe goods, where I can able to avoid the damage, or maybe I can travel long distances without any loss of comfort. So when you are included then active suspension systems. Similarly, brake by wire technology and tire sensor systems. So these things will assist the driver or maybe assist the vehicle in terms of reduction or maybe fatigue to the driver and better driving experience by adopting these technologies into the chassis. Similarly, when you are able to add the technologies at the interior level, that is at the body inside, vehicle body inside, there will be inclusion of the telematic systems. These telematic systems will plays an important role to communicate with the infrastructure at the outside. So during an accident, if you want to call to the nearest police station or maybe nearest hospital, nearest fire station, this telematics is basically, we can say that a communication between the infrastructure as well as the vehicle, or maybe sometimes vehicle to the vehicle. And the safety systems, as I mentioned, if the vehicle is equipped with the safety systems, more sophisticated safety systems, then you are the safety traveler, as the population of or maybe mistakes given by the driver as day to day increasing, and more fatal accidents are taking place in India, especially more accidents are taking place. At that time, if you want to survive more, then the safety systems are mandatory inside in a vehicle. So if you take in a US, there should be, they are offering 6 airbags as a mandatory. In India, 4 airbags as a mandatory. Day by day, the safety regulations are increasing. Similarly, the awareness among the customers is also increasing on as the years goes. So they are looking for more safety. That is the success story of the Tata Nexon right now. The Tata company is, whatever the products they are developing in India, they are maintaining high safety regulations. So in order to attract the customers, right now any other manufacturer also, apart by looking at Tata, they are also doing same kind of marketing strategy by increasing the safety of the vehicle, crash testing of the vehicle. They are increasing, even though the crash is occurs, the persons inside the vehicle will be safe. And similarly the comfort system, so if I want to travel a long distances, the comfort is the mandatory in terms of providing, the AC systems, or maybe wiping systems, or maybe any other safety systems which can provide the luxury to the driver, or maybe which can reduce the effort to the driver, while assisting system to the driver which can reduce the driver operations while while driving the vehicle. Those will comes into the category of comfort. And similarly entertainment systems, if you want to travel a long distances, the entertainment is also nowadays the customers are expecting, these customers expecting the entertainment in terms of, previously we have Wi-Fi, now in inbuilt studio systems like video systems, video players, audio players comes into the picture. That is also the customers is expecting. These are the mandatory. One thing you can remember here, these systems are not mandatory in a vehicle for propelling on the road. For propelling of the vehicle, basic structure is needed. But in order to meet the government regulations, or maybe in order to meet the customer needs, these are mandatory. Otherwise your vehicle will be not right size for the customers. In that particular context, everybody is looking for updation of technology. And in terms of the body level, as I mentioned, the body is main source for the weight of the vehicle. That's why new material application is needed. And adjustable crash structures, if an accident is occurs, if the body structure is designed in a such a way that it can able to attract most of the forces to avoid, or maybe to transfer into the vehicle body, then the persons will be safe. Even though the safety systems are available, if you designed a vehicle body which can having more toughness in terms of absorbing the energy due to the crash, then the persons will be safe. So that's why we need to go with the adjustable crash structures also inside a vehicle. So these are the possibilities where I can able to implement the technologies. Similarly, if you are able to see the evaluation of engines, so different from OEMs they are supplying. So nowadays you can see single cylinder to the 8 cylinder V type engine. There are different engines which are available with the different technologies to meet the government regulations in terms of adoption of electromechanical injection systems, and adoption of a different coolant technology and different new material applications, so that I can able to see the complex structures and adoption of technology, so that I can able to meet the government regulations and attract the customers. So in order to develop these technologies, the most important point inside the engine is adoption of electronic systems into the engine. So the basic adoption of engine technology includes started for better control of the engine. So like how vehicle we are controlling in terms of by operating braking system, steering system, similarly acceleration pedal. So similarly, in order to control your engine for the better fuel economy and to reduce the emissions, we need to control the engine here by adoption of electronic system. So better controls for the engine. Similarly, first electronic parts were introduced, control various engine functions, and referred to as an ECU. Basically, we can call it as a uh, electronic control unit, or maybe engine management system, and engine control module, and electronic control system. So all these terms as single, so which can main intention is here control various engine functions. So what is the basic engine function is nothing but to deliver the power, to generate the power. In order to generate the power, we need to supply fuel and air into the engine. So that means other functions of the engine, or maybe other sub functions of an engine includes taking up the fuel, generation of the power, and send off or maybe sending off exhaust gases from the engine. So for the next cycle, so all these functions will be controlled by your engine control system. When I have to inject the fuel, when I have to send the exhaust gases out, so all these functions will be taken care by engine electronics. Similarly, in 1960s, basically, uh, engine output torque and RPM were controlled with the help of engine electronics by using some kind of mechanical, electrical, hydraulic systems. So now in 1970s, electronic control systems were introduced inside the vehicle. So that is your basically electronic ECA system, electronic control units. And one of the most demanding electronic parts of the automobile is the engine control unit. So because it's a basic source for the power, and it also need to meet the government regulations, legislation and environmental issues. And so highest real time deadlines, as the engine itself is very fast and complex part of the automobile. So engine controlling is one of the important parameter before designing your vehicle. The safety systems which we can include inside the vehicle body, and power drivetrain systems will also comes into the picture. But only thing you can remember that in order to meet, apart from your safety regulation and other regulation, the first and foremost thing for the vehicle or for the OEMs is adoption of the technology in order to meet the government emission regulations. Otherwise, it is very difficult to launch their vehicle in India. That's why every manufacturer is looking for adoption of engine technology inside the vehicle. So, so basic, if you are able to see, uh, the basic the role of technology in terms of electronics, 40% of the vehicle cost nowadays, 40% of the vehicle cost nowadays is determined by the electronics and software. So as I mentioned, if we want to adopt the technology inside in a vehicle, we need to introduce the electronics. The electronics is everywhere now, in the engine level, safety level, comfort level, entertainment level, telematics level, body level. So now, as I mentioned, 40%, but nowadays it is increased. So as the electronics part is increases, the cost related to the electronic parts also increases. Now it increases to around 60%, I thought. And 90% of all innovations driven by whatever the innovations at the engine level is happening, or maybe the vehicle level is happening at the electronics level only. So because the introduction of the, if you see from last 50 years, there is no change in the tire structures, there is no change in the what we can say axle structures, there is no change in the differential structure, there is no change in the gearbox structure. Maybe the complete innovation is happening in terms of electronics only, how better you are controlling it. All the mechanical parts are saturated, so their function maybe we can define it in terms of new material application, or maybe the complexity decreasing like that only. But the innovation is happening at the introduction of control systems, or maybe better control of the things inside a vehicle. And 50 to 70% of development cost for the ECU and related to the software. That's why you can see the role of OEMs is here just nowadays is limited to only development of a vehicle body, remaining all the technologies they are adopting from the different suppliers like Bosch, Continental, like other suppliers, OEMs. So otherwise the technology innovation will be not happen. Like Hyundai Mobis also nowadays emerging, and ZF technology. So all these are technology based companies. They are supplying their products to the OEMs for their adoption, for meeting the government regulations. The OEM will always think about the government regulations. Once they think about the government regulations, they will need a technology. They will for their vehicle. So the technology will be supplied by the respective companies just now mentioned. So OEMs have a license to say vehicle in India, to sell their vehicle in India once they made the government regulations. So that's why we can see 50 to 70% of the development cost happening at the technology development only. So if you see premium cars having 70 ECUs connected by 5 system buses, this is the best some of the example I quoted. Right now the technology is happening in a such a way that when you're dealing with more electronic system, again it's a complexity. So to avoid the complexity, we are able to generating a central ECU. For this central ECU, all individual system level ECUs will be connected. Instead of operating individual ECUs, we are only generating a central level ECU. That kind of innovations are going on at present. So those single central ECU will connect or maybe control all subsystems ECUs. So otherwise the electronics also becomes a complex in the future, especially for autonomous vehicle. So you can also think about, as the technology innovation is happening, the cost related to the vehicle with related to the electronics is increasing, the overall cost of the vehicle will be increases. So you need to maintain a synergy between the customer requirement with respect to the cost point of view. If you develop a more sophisticated structure with more safety, high end telematics, and everything you included in your vehicle, but the cost of the vehicle will be goes down, the cost of the vehicle is very high, so that the customers who are looking for that vehicle will be very low, because the affordability of the customer is more important. So by leveraging both, by balancing both, we need to develop the vehicle. That's a more and more important for the OEM's point of view. That's why you can see growing system complexity. That's why if the complex system is there, then the maintenance or maybe diagnosis is also difficult. So that is also we need to taken care. So, and the cost, just now I mentioned, if the cost is very high, nobody will purchase your vehicle. By leveraging both, then only we can do the things. So that's why you can see the motivation for the engine electronics is the motivation for the engine control, electronic control, has came to regulate automobile exhaust emissions and improve fuel economy. These 2 points will address these 2 points will address the government regulations or maybe government stringent emission norms. So in order to do that one, we need to adopt unnecessarily or maybe mandatory to the technology adoption inside the engine in order to meet these exhaust emissions and improve fuel economy. And legislators all over the world specifying increasing tougher emission limits for the engines. So because engine is a power source which can generate the power and also generate the emissions, global house gases sometimes. So those emissions should reduce, otherwise it is very difficult to meet the promises made by the individual country, like Paris agreement or maybe other agreements or maybe environmental changes. The government also looking for better life for the human beings. That's why you can see Delhi NCR region now diesel vehicles are they are banned it, or maybe nowadays the recycling scrapping policy comes into the picture in India, and nowadays they are introducing green hydrogen policy and adoption of CNG and adoption of ethanol and adoption of biodiesels. All these are meeting to meet all things are government emissions. Otherwise it's very difficult to control the emissions with the uh, what we can say exponential increase in the vehicle population. So to meet all those things, we need to adopt the engine power source. If we are able to change the drivetrain, like conventional engine to the battery operated electric vehicles or maybe motor operated, so for that also we need electricity. That electricity is conventionally if you are generated through the power plants, again it is adverse, it will give you adverse effects. So that's why they are looking for another alternatives which can meet zero emissions. That's why the green hydrogen comes into the picture. There is another topic, but here what the intention of the government, it is not happens in a single day. That's why they are shifting from stage by stage stages. That's why we can say from BS1 to BS6, or maybe in BS8 and BS9 of there we can't say that there is no engine in the vehicle. That kind of norms will comes into the picture. So that's why we are going to see the first topic is concept of electronic engine control system. So the engine control system is basically introduced, again I'm mentioning here, to reduce the emissions and to improve the fuel economy when you serve these two purposes, obviously I can meet the government regulations. If you see before that engine control system, as I mentioned, advanced engine control system, the first term, the control system, what basically a control system will do. Control systems are the systems that are used to regulate the operation of other parameters. So if I introduce a control system, it can control some of the parameters like fuel intake. If you talk about the engine level, if you can talk about the fuel time of injecting, and the time of generating the energy, and time of sending the exhaust gases from the engine. So all those will be the control parameters. The objective of control system is here to determine the output of any system being controlled in relation to the input and in accordance with the operation characteristics of the controller. For example, if I need a particular output from the system, for example, if I want to generate a 5 kilonewton, or maybe we can say that 5 newton meters of the power. So for 5 newton meters of the power, I need a certain input for the engine. The input should be in terms of supplying the fuel into the engine. In order to supply the fuel into the engine, I can able to control my accelerated pedal, which in turn controls the throttle. So in order to do all those things, in order to meet particular output, that particular output will satisfy the road requirement, maybe climbing in a bridge or maybe any other requirement, going with high speed, any other, that is an output I needed. So for that I need to supply or maybe control the input. So basically here, to determine the output by controlling the input, that's a basic operation in accordance with the operation characteristics of the controller. So that's a basic important point. Whatever the output I needed, for that I need to supply a proper input, so that with the help of a controller. So the output of an electronic control system is the electrical signal that must be converted into mechanical action. So so basically these mechanical actions we can able to do through the actuators. The input may be the to the controller, maybe electrical signal, but output from ECU also electrical signal, the output is given to a some mechanical device which can actually a regulated by a ECU. So basically the structure will be looks two cases, that is open loop system and the closed loop system. So the closed loop system, just back, the closed open loop system having there is no kind of feedback. So like what is the output, for that what is the input, it can calculates and supplies, and it can't ensures that whether my output is meet by 90% or maybe 100% accurately I am sending, accurately I am producing it. So that kind of feedback will be not occurs through the open loop. The closed loop system always ensures that it can ensures that the relation between input and output, whether you are matching the output or not with this input. If it is not matches, it can adjust the system at the input level and matches with the output. So otherwise the my achievable things will be not done. Whatever my target is there, that will be not achievable with the open loop system. That's why the closed loop control systems are there. So you can see the automotive engine control has both open loop and closed loop system. Now everybody is looping for only closed loop control modes only. So if you take an engine, as I mentioned, the control system, engine electronic control system will control the parameters to have a synergy between input and output. For that we need to understand that what are the things I can able to vary, or maybe what are the things I can't able to vary the things inside an engine. So for that you can see what is meant by parameter, and what is meant by what the different parameters are there inside the engine, and what are the variables are there, how we are able to do that. If we able to see a parameter, that is a numerical value which are included in the design of engine itself. We can't change it, we can't change it. So but with these things we can't able to control through the engine electronics. Only variables are we can able to control it. Once the engine is designed, we can able to control the quantity of the fuel is entering, or maybe the time of injection of is varying. that is in terms of mass flow rate, fuel flow rate, and in terms of when I have to provide the spark, when I need to control the power, at what time I need to control the power, and intake manifold pressure, vehicle speed, etc. All these things are variables. When I control these things, automatically I can control the output from the engine, like the power. So if I are able to control the variables, then only I can able to control the engine operation. When I will control the engine operation, I will get minimum emissions, maximum fuel economy. Okay, so if we take an engine management system or maybe electronic engine control system, is basically responsible for controlling the amount of fuel being injected and for adjusting the injection timing. So if you adopt a technology inside an engine which is basically responsible for control the amount, when you are able to control the amount of fuel, obviously my fuel economy will be increases. And when you are supplying a proper amount of fuel for proper amount of air for 100% combustion, obviously my power output will be more and emissions will be less. If you are supplying more fuel, less air, or maybe less air, more fuel, so all these things will lead to a more emissions that is not acceptable. So in order to address those things in a mechanical point of view, we introduce this electronic engine control system. This basically controls, one of the important parameter is controlling the amount of fuel, and second one is at what time I need to ignite the mixture. If you do not able to properly ignite the mixture, that will also leads to more exhaust emissions. In order to do all those functions, we introduce a precise technology, that is engine control systems. So optimum function of EM ensures the, just now I mentioned, if you are able to adopt a technology which operates with 100% efficiency, 100% reliability, 100% accuracy, which can ensure that maximum engine power with lowest amount of exhaust emissions and lowest fuel consumption. This objective is common, this motivation is common, the intention is common, the intention of every manufacturer is common, the motto or maybe the customers view also is common here, that is more fuel consumption is not acceptable. That is the main intention. When you are able to control the fuel consumption, obviously I can able to control the emissions indirectly. When you are not burning means there is no less, there is less emissions. Similarly, when I am able to get with low emissions, but what I am expecting is with low fuel I need to get maximum power. So this is a basic driven factors for the attracting the customers here. So somebody wants more fuel economy, so then I can able to satisfy. The government wants less polluted vehicles, I can able to satisfy with this technology. And there are two major functions powered by EMS, that is engine management system, that is to provide the spark at the right time, to meter fuel to the engine at the right quantity. Here the meter is nothing but measurement. So we can able to supply a proper amount of the fuel for the proper amount of air, so that 100% combustion is happens and 100% efficiency will occurs for the engine. In terms of fuel ignition, 100% fuel will be ignited with minimal emissions, minimal losses, so that I can able to get maximum fuel economy. Okay. So if we able to see further role of engine management system here, uh, basically this engine management system, as I mentioned, reduce the emissions and control the emission components. So once you are able to reduce the emissions, the engine emissions, as we know, the basic engine emissions, if you're able to take CO, HC, NOx, and greenhouse gases, CO2. So these will be the major engine emissions. When you are able to control all these emissions, I can able to control the environment for better life being for the future generation. And similarly, if your something is related to exhaust, and when you are able to adopt the technology, it can also need to ensure that malfunction detection. So if something is malfunctions, I can't able to run the vehicle. So that's why it can able to provide the diagnosis options warnings to the driver also. And further, one of the most important parameter is the minimize fuel consumption and meet legislative requirement. This I'm talking from starting of this session also. This is the most important parameter, the driving factor for this. And further, it can reduce the evaporative emissions. When you store the fuel at the fuel tank, it can, the engine management system also reduce the emissions at the storing point of view also. And when you are able to get 100% efficiency in terms of fuel consumption, acceptable fuel consumption, then I can able to get acceptable drivability, ensure smooth drive. That's the basic intention here. And which is consist of a wide range, as I mentioned, wide range of electronic components. But the basic components will be the sensors, actuators, and engine control unit. If you take any kind of electronic control system, not only the engine control system, electronic control system, basically three parameters which can decides, that is sensors, that is input to the control unit, and actuators, it can takes the signals from the ECU. Basically these actuators are mechanical parts, mechanical units. So not only these parts, when we are dealing with these three parts should integrately work together. Otherwise, the input is different, the controller, the electronic signal from the ECU is different, then the output and input are, the relation between them is goes wrong. So my intention is here, both input and output together works to get maximum fuel economy and minimum emissions. If there is no relation between the input and output parameters from the from engine control unit, then the adoption of this control unit is not at all acceptable. That's why they work together, provide engine management system here. That's a basic thing you can able to see. The engine management system incorporated in the modern day technologies such as MPFI, that is multi-point fuel injection system, gasoline direct injection system, and common rail direct injection system. These systems we will discuss in coming sessions. So in engine control systems, as I mentioned, provide sensors will provide measurement of engine important engine variables. As we discussed, the engine variables is mass flow rate, fuel flow rate, or maybe temperature, intake temperature of air, and maybe manifold pressure. All those will be the different engine parameters, or maybe the engine RPM. So all those will be the engine parameters. These sensors will just senses at what RPM the engine is running, at what flow rate the fuel is entering, at what flow rate the air is entering, what is the temperature, current temperature of the engine, what is the coolant temperature. So like that, it can always senses those information. So if the different driving conditions will be comes into the picture, for example, if I want to travel with high speed, I need to supply more fuel flow, then the sensors will give the information what is the current state of the fuel flow rate. Based on that, the ECU will decide what is the driver is expecting, that based on the position of throttle. So the driver is expecting that more speed, then ECU will instruct the actuator, that is injector, fuel injector, to supply more fuel. It's a basic thing. So the similarly, actuators are electronically operated device that regulates input to the engine, that directly controls the output. So when the output is high, that is in terms of more power is needed, more fuel it is supplied. So once the more expressway is completed, if I'm traveling on expressway, then I obviously I can go with the high speed, then my output needs more high. So then the output will decides the input parameter here, that you need to understand here. If I want high speed, that is my output. Based on that, I can provide the input by controlling the throttle cable. And engine control unit is a central part of the engine management system, which virtually we can call it as the brain of the engine. So just it can intermediate member in between the input and output, and it is also intelligent. So maybe in the next session we will try to look into about what is the basic structure, what is the basic schematic view of engine control unit, and further we will also see about engine management system, so how it will be works. Thank you for the day. Thank you. Signing off for the day.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.